Very welcome, and thank you very much for attending this event. And I'm Botan from Temple University, and our university is the coordinator of this project. And it is a great honor for me to take this chance to introduce our project. And it is Maria Carey Action Research and Innovation Staff Exchange Project. The topic it is on the deep intelligent optical and radio communication networks. And so I actually at the beginning I gave this. Sorry, let me try to. I give this agenda up today. So as Svetlana already introduced the agenda, so I will skip this step and quickly go to the introduction of the project. And also I would to thank all the speakers today and paying the time and effort to preparing the materials for the events today. Okay, let's go to the introduction of the project directly. So here I gave here are the basic 6 topics I covered in this quick brief introduction, including the background, why we propose this project, and what is the technological approach we have, and what type of consortium we build to implement the technology approach, and what the expected impact and what achievements we have done so far, and what is the next movement. So let's go to the background. So we actually prepared and submit this proposal at 2020. So during that period, we have seen the commercial 5G system deployed in different country and regions. But in the research community, people start to look at the 6G and the envision the use cases that beyond the capacity of the 5G, including the telepresence and also the extend or mixed realities and the support of the autonomous system or swarms. So this use cases probably become the driving force of the new requirement, and the research community identified 6 requirements and characteristics of the 6G service or network. And it is written in the white paper of Nokia Bell Lab. They mentioned the requirement on the throughput and the capacity and the low latency and the scalability and the flexibility on the network coverage, and also the extra function on the positioning and sensing, and as well as the adaptability of the network management, and as well as the energy efficiencies as well. So in order to meet these requirements, people start to look at the new spectrums like millimeter wave and terahertz, and also the more complicated system like massive MIMO or large scale, even larger scale antenna systems in order to have higher data rate and lower latencies. And meanwhile, they make the network very complicated to managing. And actually, what we spot is the opportunity of the convergence of optical technique and radio technique. The reason is that I think on the for the bandwidth on the optical spectrums provide more like uh, actually much larger bandwidths compared with the radio spectrums. So it could be a potential good resources to provide the high speed and the low latency performances. And also the photonic techniques can help to enhance the radio signal generations for the high quality and wideband radio signal generation, and as well as like the progresses in the free space opticals and visible light communication. That could be some extra options for the access network design to give more flexibility and scalability, and also the to applying the optical fibers on the front haul. That could be a good option to reduce the energy consumption and also the operation cost as well. So that's why we notice like the besides the millimeter wave and terahertz, the convergence or interaction between the optical and radio techniques could be also good options to meet the requirements of the 6G system. And also, like besides this like user-driven factor, we also noticed that another factor we can't really avoid is actually machine learning. So besides the when we design the 6G system, so we need to consider the spectrum and the spatial efficiency that is also considered in 5G. But actually, the availability of the data and the computing resources gives us new dimension of the consideration when we're designing the 6G system. So actually, uh, the machine learnings, we noticed that machine learning can apply on the different levels in the communication system, including the components characterization in order to improve the signal quality. That could be including both the radio signal and optical signal. And also the learn-based or maybe the data-driven based processings can be reduce the capacity of the physical layer and link layer algorithms, especially on the receiver side. Lots of iterative algorithms need to be need the lower capacity replacement. And also like the machine learning can be also used for the network resource optimization and the improving the automation level of the network management. And at last, I think the machine learning is also widely used for providing the intelligent applications. And because of the widely deployment of the computing resources from the core network and the edge of the network, so the artificial intelligence itself can be provided as a service for the users in the mobile network. So this is the general background of like when we propose this DIOR project. So actually, we need to actually to look at what actual approaches we included in this project. So from the picture, you can see that in the future 6G infrastructure, we have like the optical technique and the radio technique. They are closely interact and coexistence in the user domain and the front hall and the back hall. So actually, in the DIOR project, we actually proposed the four different technology work package to tackling the to applying the machine learning to help to improve the network performance from the signal and link level and also the network level. So for example, in work package 1 and work package 2, we focus on applying the deep learning method to improving the signal quality and also the link quality for both radio and optical links. And there are some like shared common method. For example, the deep neural network, they can be used for modeling the nonlinear impediments for both the radio components and optical components, especially for the power amplifier. So, and then if we can model these nonlinearities, we can actually apply some compensation mechanism like digital pre-distortion to improve this the signal quality. And on the radio side, the machine learning can be also used for the beam forming, especially for the beam alignment, and also the end-to-end optimal learn-based radio link. So on the optical side, the machine learning also can be used for the on-demand wavelength adaptation. So besides this signal and link level improvement by the machine learning, we also propose the WP4 and WP3 to help to more to optimize the network performance. That will include the temporal and spatial modeling of the network traffic. And based on this the modeling of the network traffic, we can predict the network traffic and to optimize the resource allocation and the task scheduling between the different network components that will be including the optical components and the radio components. And at last, we'll create the coordinative mechanism for the network management with hybrid optical and radio networks. network components. So this is our basic the technical approaches we proposed for the project. And then in order to implement these technical approaches, we build this consortium. So we have experts from the radio side. That mostly we have Tampere University from Finland and the Kharkiv National University of Radio Electrical Radio Electronics from Ukraine. We have experts from to deliver the radio techniques, and also we have experts on the optical techniques. They are from the University of Warwick in UK, and also Institute of Telecommunication in Portugal. Besides the universities, we also have two startup company, Scan and Turin Tech. They are from Ukraine and UK respectively. They will give us support on the developing the machine learning models and also the computation effective machine learning method. And besides these partners from Europe and the UK, we also have two universities from China. It's Fudan University and Tianjin University. They will enhance our research on the radio and optical respectively. So we can see that we have a very diverse and balanced consortium. We covered the from east east to west and north to south Europe. And we have this excellent consortium, and of course, we will also have some expected impact. First of all, as it is the MSCA project, we are looking at the excellent technology innovations. For example, we are developing the deep neural network to model the nonlinearity and or stochastic models for the optical and radio signals, and build the temporal spatial modeling for the network traffic forecasting and the optimal resource allocation and autonomous network, especially once we have network components from both with both optical and radio components, and as well as the low complexity machine learning methods. And also it is the research and innovation exchange program. So we will also expecting the knowledge and skill exchange between different domain, field, and sectors. For example, we will have a staff exchange between the radio and optical technique, and from signal to network level, and also the staff exchange between the communication and AI, and as well as between the academic sectors and industries. And we hope during this staff exchange, and we can help our early stage researchers to gain the skills in different fields and diversify their career development opportunity. And also, like for our experienced researchers like myself, not I hope like I can extend my research network in this program and to accelerate my research development. And for our startups, we hope that they involved in this type of the research program, and they can have a taste of like what is happening in the research community to help them to identify more business opportunities. And besides the career development, we also see the opportunity of the sustainable collaboration inside of this consortium. And we're looking at the integration of the optical and radio in the 6G infrastructure design. We also see the opportunity that this is also mentioned in the other EU course. For example, like in the 6G SNS joint undertake, they already have a clearly mentioned that the convergence of the optical and the radio will be the when in their is one important direction in their course, and on building the future 6G infrastructure. And also, like we think we can extend this DIOR program into a MSCA doctor training network. So this is how sustainable our collaboration may be. And besides this technique and knowledge exchange and career development, we also look at the gender balance in this staff exchange. We will promote the gender balance, And from the last picture, you can see that we designed a real balanced exchange schemes between the sectors and between the knowledge field. And then with this expectation, and we have some achievements already. So this project actually starts from 2022. So we already done almost like 50% of the administrative deliverables and 20% of the technical deliverables. And we implemented around 32 to 36 secondments already. But to be honest, we have a little bit slow pace here, but we have some reasons. We actually have a very difficult year this year. We still have around 300 secondment to implement. And also like we build the website and social media account and also like subscribes and like to promote our research outcomes and concept in the community. And also like you can see that at last we did very good on the dissemination. We published over 20 papers in the first year, and thanks to our our fellow researchers. And also we have the workshops and the special issues is planned in some conferences and journals in 2023. So at here, I would like especially to see something like in 2022, it is very difficult for us because we have two partners from Ukraine, and they are experiencing a very difficult year, like in the shadow of the war, and also almost have serious impact or maybe destroyed their work. And but even though in such difficult situation, they still actively participate in the project and contribute to the project. I would say deeply grateful for their contribution, and I would to express our solidarity to them. We are together with them. And based on this achievement, we will have a plan for the next step. We will actually continue the excellent technology development, and meanwhile to enhance our exchange implementation. And at meanwhile, like because this project is for the staff exchange, so that means we have to rely on our full-time researchers from the other projects. So we actually closely interact with the other national and international projects that include the Access project and the 5G PSS project. They are sponsored by the Academic of Finland and the Business Finland, respectively. And also we have the next generation optical wireless communication enabled by the artificial intelligence that is funded by the Foundation for Science and Technology from Portugal. And also we have the UK funded project OLSM 5G. So, and as I mentioned that we have slow pace of the implementing the secondment, so potentially we will have to extend the duration of the project to 2027. And in order to have the more options for implement secondment, we will introduce some new partners to keep on expand our network. So our potential new partner, including the Huawei from France, and the Newcastle University from Australia and Suzhou University from China. So by introducing these new partners, we will help us to actually to have more options and diversify our options to implement this secondment. So hopefully we can have the full implementation at the end of the project cycle. So that's pretty much all of my introduction of the project. So thank you very much to spending time for this event. I hope you enjoy the following talks, and especially the technique talks, the technique development that we have done during the projects. And I also appreciate if you could join our social media, including the Twitter and the LinkedIn. You can scan the QR code here, join that easily. Thank you very much.